Hello, and welcome to Calculus Lesson 41. Today, we are going to expand our knowledge of graphing rational functions. And the way we're going to expand it is as follows. So, we are now going to get gross things like this. Okay, so as you've noticed, we have a couple of odd strange terms. Let's add another x. Okay, so let's go through our normal process, and then when we get to those strange things, like how we deal with these powers, then we'll address them there. So the first step is that we have to look at end behavior. These may also be called horizontal asymptotes. So how do I find the end behavior? Well, I'm going to take the limit as n approaches infinity, or as x approaches infinity, of my function of that thing. Now let's look. I have x squared times x, that's x to the fifth, plus a bunch of other stuff, over x times x squared, that's x to the sixth, plus a bunch of other stuff. All right, all the lower power terms, once we're at x approaches infinity, are going to go away. So this equals positive 0, right? If I plug in a positive number, this number is going to give me a positive number out. Similarly, if I take the limit at negative infinity, plugged into x to the fifth is going to give me a negative. Here it's going to give me a positive. This one's going to be bigger, so it's going to be negative 0. So what that tells me about my function already, which I will graph way over here, is that at infinity, I'm going to approach 0 from the positive end. At negative infinity, I'm going to approach 0 from the negative side. All right, now let's get back to this. After we look at end behavior, I did not leave myself much room. Oops. So I never do that. All right, now we're going to look at zeros. So that's when the numerator equals 0. So I'm going to set x squared plus 2 times x minus 1 squared times x equal to 0. Now here's the trick. This tells me that I have a 0 at 0, 0. If I plug in 0 for x, I get 0 out. Okay, there's none of those terms on the bottom, so I'm fine. Here, if I plug in 0, or if I plug in 1, I get a 0, and you can't really read that. So let me do that in a darker color. There we go. My blue marker has disappeared. It's over. So this is going to be 0, 0. We'll mark that. This is going to be 1, 0. Right, if I plug in 1, I get 0 out. But notice that it's to an even power. So if you have a 0 to an even power, that's a touching 0, as opposed to zeros that are to an odd power that cross. What does that mean? Well, instead of going across the x-axis that we're normally familiar with, it's merely going to touch the x-axis. So here at x equals 1, be careful not to label the y-axis because you really don't know the y values of this function, but you can label the x-axis. So this is a crossing 0. I expect the function to cross there. This is a touching 0. So I expect it just to touch there, like in x squared, where it just touches the function but doesn't actually, or it touches the x-axis but doesn't actually cross it. Okay, let's keep going. We'll need our function back. There we go. Okay, so we found our zeros. This will never be 0. Remember, x squared, the lowest number it gives you is 0, plus 2. That's never going to be 0. So we just ignore. Now, let's look at our asymptotes, okay? That's when the denominator, or vertical asymptotes, that's when our numerator equals 0. So these are going to be lines, since it's an asymptote, it's a vertical line. So what am I going to do here? I'm going to figure out what makes any of these 0. So x equals -3, x equals 2, x equals 3, and x equals 6. Now here's the trick. When you have these to an odd power, they're your normal asymptotes that you expect. So the function goes down, then it comes back from the other side. When you have even powers, these are your volcano ones. So remember, 1 over x squared looks like this, where it goes up and then it comes back down. 1 over x looks like this, where it goes up and then it comes up again. So you just have to watch out for the 2 different types of asymptotes. So we'll graph those, and then that's going to be our lesson. So let's go 1, 2, 3. All right, so we have an asymptote at -3. We have an asymptote at 2. These are normal. And to distinguish the weird ones, I'm actually going to do them in a different color so that I do not mess up. So x equals 3 is one of those funny ones. This is going to be a volcano. So if it goes up, it's going to come back down as opposed to going from the other side. And x equals 6 is also a volcano. So now that we've done all of that, let's start connecting the dots. I'm going to start here. I don't know why I always start at the right side, but I do. So we'll go up this way. Since there's no 0 here, my only choice is to go up the asymptote. Now, since this is a volcano, it's to an even power, then it's going to come from the same direction. There is no 0 here between these two, so I have to go back up the asymptote. This marker is dying. I missed. All right, now this one is also a volcano, so it must come from the same direction it came from. Oh, that was a tight fit. Make sure you don't touch your asymptote as you're graphing. Now this one is not a volcano, it's a normal asymptote. So if it goes up, then it must come from the bottom. Okay, now here's where it gets tricky. This is a touching 0, so I can only touch it. I kind of have to come away from it. But that's a crossing 0, so I have to cross there. So I have to like loop. It's a little tricky once you do it for a while, or once you like do it, check your answer on a graphing calculator and go, oh, that's what it's supposed to look like. Then that helps a lot. So this cross, now we go up. From here, this went up, so now I must come down. If I did all of these correctly, it should line up with my negative infinity, which it does. And that is problem set 41.